Okay, audio check. 1, 2, 3. Okay, sounds good to me. So, I guess we can get started. Just getting everything lined up where it needs to be. Okay, ladies and gentlemen, welcome to the Discourager of Hesitancy. Today is compiler day. This is like my off day, my play with something else day. We are building a compiler from scratch, no libraries, no dependencies, just the standard library. And we're doing it in a way I think is fun and interesting and educational, but probably not the right way for most people's projects. We're writing a tokenizer generator instead of just writing a tokenizer. The tokenizer would be far simpler, but why do things the easy way when we can learn by doing the hard way? So we are taking our input file, our configuration file for a tokenizer, which looks something like this. Let's see here, B tokens. And you have the name of the token, your actions of that token, and then the regular expression for that. And we are using a Thompson construction to turn these strings into an NFA, and then we're compiling that down to a DFA, and then we're emitting code that looks something like, oops, that's here, source VV test project. Looks like this. Now, this is not as bad as it looks. The reason it looks this way is because every time I have a meaningful decision to make about that may affect performance, we are making it in every way possible. Okay, so for example, reading files. Well, we can use the system level open call and file and read calls. We can use the library level file calls, or we can use modern C++ file streams, right? So those are all options. We can iterate different ways through the string that we read in. How we dispatch our functions. So you can see that by the end of this, we've got hundreds of combinations of things to try. So eventually, we'll need to write a script that builds using each of these combinations and runs a suite of performance tests. But we're not testing performance yet. What we want to do is have everything functional, and once that's all clean and done, we're going to build up a nice little performance test suite. And then script out building with every combination of performance switch and just try them all out and see. Now I have my predictions, and but even then, like, maybe I'm right, maybe this one's a little bit faster than that one, but is it a meaningful amount? And which of these parameters has meaningful impact? So we're gonna play around with it. Like I said, we're doing it all entirely the wrong way. There is so much duplicate, quadruplicated code that we've generated because we need to make it work for every performance switch, which is kind of fun. This is more of a hobby learning thing than a serious thing. Once we do have that high performance figured out, then it'll be time to get the performance benefits from the other things, such as looking at maybe SIMD or multi-threading. I don't know if I want to do that just yet. I think I may want to write the LALR parser generator next before we start thinking about multi-threading. But this is sort of the long-term plan. For today, well, what we've got here is last time we fixed the newline pattern. There was a bug in my code. Shocking, I know. And we've got the text buffer tracking lines right now, so we can print those out. but the line it returns contains the new line characters themselves. So it won't make a nice printout for, the line of text and then the nice little, indicator underneath the line of where your token is. So we got to remove those. In the last few minutes last week, we tried real quick, but it didn't work. So we're going to revisit that this morning so that we can print out a token with its line for context. Because that's always nice. A lot of times it's good to have the line in which your token is in its context to help in debugging. You'll look at it like, oh, I know what that is in the code. Oh, I know what that is. So we'll revisit that one. Then we have a bug with strings. There's something about the string pattern, regular expression pattern, that makes me sad. So we'll look at that. That's the plan for the day, but we'll see how far we get. In theory, neither of those should take too long. Trim trailing white space in TxtBuf lines. Fix string regex pattern parsing. Okay, so that's about what we're up to. So if you have any questions, comments, concerns, let me know. Always happy to chit chat about just about anything. Otherwise, we're going to dive in. I've just about got my beverage for the day ready. Pretty standard yerba mate. Got my gum ready, and here we go. Yeah, last week was a very short stream, so we didn't get very much done. All right, let's take a look. This will be in the TechDebt. Codes of it. We define a line. We tell it what character to start with and what character to end with. Yeah, for now the line count is static. I don't really care. Think about data types and that sort of thing right now. So we get our character at the end. And if it's a new line, actually, didn't I overload equals to do this? Pretty sure. Character reference UTF-8. Other or a value. Yeah, okay, so we're good. C equals a space, or C equals a tab, or C equals, and we do support UTF-8, therefore. Let's go to our test parser, and I happen to know that non-breaking spaces are in here. Okay, so if our character is equal to any of those things, try to back up one character. Now, in the case of ASCII encoding, which we support, and Latin 1 encoding, which we support, it's trivial. You just move back one byte. But back one. We move our character offset backwards one byte, or one character, because a character can be multiple bytes. Then we're going to count how many bytes we retreat. We're going to say, go back one byte. Oh, I see. Oh, well, that's interesting. Let's do this a little bit. New byte offset, byte offset, and then we also want the new byte count. Oh, nope, that's it. New byte offset. Bytes retreated equals 0. And then what we're looking for here is a UTF-8 continuation byte. Okay? So what we're looking at is the top 2 bits of the byte. And if it equals 1, 0, right, so this pattern is basically byte 0, 0, 0, 0, 0, 0, 0, 0, 0, and 1, 1, 0, 0, 0, 0, 0 equals 1, 0, 1, 2, 1, 2, 3, 4. Okay, so does that make sense? The C is this. So we're saying take the first 2 bits and see if they're 0 and 1. That's basically what we're doing. So whatever this is here, we're only looking at these 2 bits. If it's a continuation byte, we do have to back up more. Okay, then assert that the bytes retreated byte offset minus the number of bytes we retreated is equal to our new byte offset. Then byte offset equals new byte offset. And then we update. And update looks up the new value for the UTF-8 string. So I suspect what was happening before was we were getting a \n \r, a character return new line, a CRLF, and that's no good. So let's look what we're testing it with. Oh goodness, okay. We said give me a context. We're using this text to test with. Making our tokenizer, setting its context. Tokenizer will process its context. And we'll log out all the tokens we got. Here's how many lines. For each line, log out the line. Okay. All right, clean and test. So what this is going to do is it's going to import all my new code snippets. It's going to rebuild the entire executable for VV. so let's see. So this is rebuilding the entire VV executable. Once that's done, we go in, we run VV against our test project and tell it to put the file in this directory. So it processes our project file, it writes out a parser for us, then it rebuilds the VV parser in its entirety. So this is already using the tokenizer, it's using VV to generate the tokenizer generator. And then test.cpp is where we test that output there. Something like that. So let's go to our shell. We're going to source builds debug. Might be our debug. I think so. -G. Yes, okay. And we're going to run the VV test parser. So yeah, here's where we used VV, which is from our main. Okay, we're running with these defines. The text is hello, newline, omega, world, newlines. Okay. Processing began and ended. We've commented out some code that was outputting a lot of stuff between here. We got 5 tokens, line 1, hello, line 2, omega, line 3, comma, line 3, world. No, line 2, comma, line 3, world, line 3, exclamation mark. And the lines are so close. Here's the omega. Here's world. Okay, so that's interesting. So hello trimmed off too much, omega was just right, and world didn't trim enough. It also skipped the leading white space. So these are the things we got to do. Like we would like this omega. Oh, and the comma's missing. Okay, interesting. Leading white space. So clearly we have some issues. It's not too bad. We'll just work our way through, one at a time. Yeah, it's not counting the start of line until here. Okay, so let's take a look at that. Num process. Line, character line. Get this iterator. Current. Start new token. Line. I guess here's a question. What if we go to test? Let's just change up our UTF-8. So hello has the leading spaces. Interesting. Okay, so here's a thought for me then. What is current pointed at? We don't have to do this in advance. Oops. I do not remember the rules here. Tokenizer. So let's look at the. Do I have log in here? I do have log in here. Okay, great. Tokenizer. Also. Okay, that's fine. Is it fun? Line start character. What do we want out of this? Byte offset, character offset, C string. We just get the C string of it. Byte char value. Current dot C string. Delete temp. Okay, underscore current dot offset char offset temp. What? Okay. Every time we get a new line command, We'll see what that does. We'll at least have an idea before we do the advance. It may be unnecessary to do the advance due to the way the new lines work. Space, space. Oh. Oh, that's fine. Okay, so we need to not chew up that space. We'll put the letter X in there for some reason. Okay. Basically, I want every line to have some leading and trailing spaces. Oh. Yeah, actually. Okay. Hello, omega, comma, X, world, bang. 1, 2. Yeah, so that extra advance is killing me. It's eating up the leading white space, although this one. 1, 2, 3. One, two, three, four. Yeah, so we don't need that advance. That's correct. Tokenizer. Let's comment that out for now. Oof. Let's just delete it. Okay. Leading space, or where did X go? The X is gone. Hmm. E equals end if C is any of those, back up one character. include last character equals false. In this case, I think we want true. Okay, hello did have trailing white space, and that was trimmed. Space omega comma space x. So that was trimmed, and that's showing up correctly. 1, 2, 3, 4. And world is not being trimmed. And actually, line 4 should be empty. Is it only with the last line? Let's go back into our test. Let's add more lines of junk. Things and stuff. I don't remember what the script test the tokenizer. Oh, it doesn't accept a period. Good. So there's line 4, things and stuff, and it was trimmed. Put a new line after it. It doesn't trim it properly the last line. Although the tokens are coming out nice. Last line. What happens on the last line? If we go to our tokenizer, where we process while things and stuff next state. If the line starting character So if the last character in our file, let's do this. Let's do a quick test then. Last character in our file is not newline. Now we get our blank line. Which was not trimmed. So it looks to me like we have two things. One text buffer. And, oops, that's not an and. C dot byte offset has to be greater than the start byte offset. We don't want our end to go back. So if they are the same character, we create this string reference. It should be an empty string, I think. First character has to be less than or equal to. I think everything else just comes out in the math. So, okay. That's one thing that could happen, except in yeah, that last new line is not being called. Oops. And it won't if the last character is. So let's try. We just, well, it won't matter. Actually, it will matter. Will it? So we got that trailing white space. Does it trim down to an empty string? Would be nice to know. So this line here should be empty. That's a quick, easy test. It's not. What about this then? I can see why at least some of the time that newline character would get that did not trim. Everything else did. Remove the trailing white space. Huh. Curious. We can't actually run newline the same way at the end of the file for some reason. Oh, well, here's a thought then. No. Hmm. Puzzling. All right. We'll take a restroom break and think about what's happening here for a minute. So I'll be back in just a minute. let's see. Valid reason or something. All right, new lines, white spaces. End of buffer. Okay. There it is. Okay, so we hit the end of the buffer, we can back up one. Then, in Tokenizer, try this again. Okay, well, we got that line is not trimmed. Why was it not trimmed? Oh, that's not right. What? How on earth does it think that there's an... Oh, there's an exit here. Put that there. There's the space. Take out the space. It crashes. Shoot. I think we are close, but... What is newline doing to me? Character in line. What are we doing wrong? find the line. Train new lines, white spaces, and end of buffer. Or if we hit the start jar. Back one. So question. Line start character. Pardon me. Okay. Okay, line starts at byte 0, character 0, which is a space. Byte 9, character 9, so let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th character. Oh, that logging is not going to do us any good. Text buffer. C. Yeah, that's not going to help at all if we just keep putting the end character over and over again. Okay, here we are. We back up, we back up, we back up. Oh. Okay. Back up space, we hit the X. We back up over a new line. Line 3. What's that? Back up until we get something. Line 4, we go back to the period at the end of things and stuff. Line start at 53, 52. We back up 54, 53. We back up 53, 52. Huh. So this is 48, 50, 51, 52, new line. Mm-hmm. 48. 950. That's not empty. Why is this not empty? My offset byte count should be 0. Oh. Okay. Okay. There are times when we don't want to include the last character. So yeah, basically, because of this, it adds a byte back in when we want an empty string. Which is sometimes right. Okay, so here we're going to do TxtBuf. We're going to say we can go past. We'll indicate here. If this is less than 0, if negative, byte count equals 0. That's fine. Character count will be 0. So really, offset and buffer happen no matter what. Okay, let's try that. Oops. Okay. Mine starts at 53.52 and ends at 54.53. Backs up. It backs up. Yeah, that insertion would be incorrect now. It has to be valid, or it has to be at the end of the buffer, which is fine. Okay. There we go. It finally trims that trailing white space correctly. If we remove that trailing white space, it shouldn't make a difference. In theory. Nope, it's still dying. Oh. Actually. Hey, there we go. Ooh, okay, so now we're printing the lines. Perfectly. That's good. But only in UTF-8 if we tested this, so... So this is tested in UTF-8. These log statements can all go away for now, which were in TextBuffer. Okay. So these log6 will all go away. That all works. We got our list of tokens with line number and character offset inside. And we can get the lines by number. Therefore, we should be able to take a token and say print with context or something along those lines. But is this going to cause any problems in character reference for ASCII? To generalize this a little bit, this is the one thing in here that's very UTF-8 specific. So if we do this, character reference UTF-8, we want to ask, is this white space? Advance to end, update back 1. We need this for debugging, because once we hit this in release mode, it doesn't do anything. Okay, so we're happy with that. Really, back 1. We just back up 1 and update. So that's easy. I think our reference for Latin 1 is the same. Yeah, dead simple. Trivial, one might say. So string reference, UTF-8, we made some changes here. I need to check the Latin one. We work similarly. We no longer do this. This always happens. This always happens. Char count equals 0. We'll take the empty string. charts that always happen. Okay, so let's just make these look as much as light as we can. Okay. And then the ASCII will look very similar. In fact, I think it's identical. The biggest difference is UTF-8 to the other two. Latin one is different. Delete those. Take the buffer, take the offset. So ultimately these are identical. Okay. Okay, hey Pat, what's up? Oh, what's up is we're doing good. We're doing good. We are making progress. One thing I do want is right now TxtBuffer is asking encoding specific questions. So I think I need to move a check for whitespace into the character class. Is whitespace. Basically looks like that. And then it becomes trivial to put it in the others back one. So all we have to do is remove non-breaking space, as that would not be a valid ASCII character. And our text buffer, and just ask c.is whitespace. It's whitespace, or if we're at the end of the buffer. And we are past each other. Going back up on characters. I think that's that. So that should work for all the encodings. And run, and it still works. Good. Okay, so one thing we want to do is be able to print a token with context. So token of log context. Log the context in which this exists. Okay. The string ref. What do I have for string ref? Operator for equality, byte count, character count, C string hash. In case we want it later. We don't have a way to get at the buffer itself. Oh. Awkward. The string reference doesn't know about text buffer. It knows about the text buffer implementation. Basically, text buffer is a thin wrapper around the bulk of the meat here to avoid circular dependencies. The things that character reference and string reference need are in impl. Say token does not know about the buffer. Shoot. I am so close. Well, a buffer. Ooh. Oh dear. Let's see here. Token should be created with the token should know the buffer. There are things we want out of that buffer. Therefore, TextBuf buffer. We should assert buff is not equal to null. Assert char in line greater than or equal to 0. Assert line index greater than or equal to 0. We'll do that for now. Am I forward declaring? I am right there. So it's not there. Where did we put that in? Somewhere. We're forward declaring that string reference. We also need this forward declared text buffer. I feel a lot better about the text buffer actually, but that's besides the point. Oh, it's right there. Text buffer. There we go. Okay, so so token log context token now has the buffer. So where's log? Log context equals our buffer. Buffer. Line index. Main equals C string of this thing. Oh. Question about my logger. Hello? Don't think I expose a write method that doesn't automatically put in new lines. So that's a problem. Oh well. Up the line. 4 into x equals 0. Just a moment. Let me see what's going on here. Okay. We're at the line. Then for index equals 0, index less than char inline. Plus index. I think we do that. Then log note. Let's just simplify a bit. Actually, we don't need to do that at all. Hold on. Line, print out the leading space, then m underscore char count or m underscore text dot char count, right? Let's try it. All right, we're outputting tokens. Let's say we want the 0, 1, 2, third. Let's take the, well, 0, 1, 2, 3, fourth token. 4, 5, 6, 7, 8, 9. 4 and 9. context.tokens 4 and 9, we said, right? Here are the tokens. 0, 1, 2, 3, 4, and 9. Okay. Log context. Log context. I just want to see. Oops. One thing we forgot. I mean the newline character. Yeah. Doesn't like these are printfs, but it'll get us over the initial testing as we go. Okay. Well, that didn't work very well. Oh. Who's instantiating these? Oh. Okay. Context does or does not give me access to the buffer. It does. Good. That's it. That should be it. Okay, what else did we miss? All right, token line C string. Okay. Closer. Okay, I guess it returns it as a reference. This while is a pointer. I am okay with token. These should all be const. Nobody wants to miss the buffer. Okay. Oh, come on. We need it clean. Made a few changes across multiple files. Oh, so close. Oh. also must change it here. And here. Okay, okay. And it blows up. Well, shit. Let's see where it blows up. Algo base. What? Log context text buffer line. Text buffer line. Oh, I can't get it because it's private. No, is it private? This is not public. We get the line here. And that works fine. Log context buffer line. STL algo base be needed at all in text buffer line. Backtrace makes no sense to me. Vector is not in main. what's in main? I'll go base. It's probably this line here. 981. So bb test parser 981. Buffer line, which is exactly the same usage as here. Context.token. So with context right now, it's using a vector here. Is that what's crashing? Fridge. Uh-oh. Process of cooking everything. Yeah, no worries. That is unfortunate. Fridges should last forever. That's the rule. It should be the rule. Text buffer is null. Embuff line. Oh, here we go. We may have an invalid buffer. It wasn't being copied correctly. Okay. World. And that looks about right. And stuff. Oh, right there. Cool. So yeah, we get a line of context. And the carets pointing out the characters in the thing. We should also do number 2, because that's omega, which is a multi-byte character. Hey, welcome back. All right, so we've got it. We've nailed it. This is the text we're parsing. These are the tokens, and we can print. That's character 0, 2. Token 1. There we go. Okay. There we go. Now it's pointing at a multi-byte character in context. Line of context, location. Line of context, location. Line of context, location. For all the tokens, we can get their context now. Cool. For logging errors, that'll be huge. Text has 5 lines. We get all the lines, and they are trailing white space, trimmed, and do allow empty strings. So I think we're good. Perfect. We're going to call that one done. All right. White space and new lines in text buffer lines are being trimmed. There was some issues around the last line and empty strref that had to be updated. Now have a token log context. We'll print the line and underline the token in its place. Not bad. Not bad. Yeah, pretty good. We did have to do some updates to ask for white space information. The string references had to be updated to handle the empty string ref. And token was updated to have the log context. The tokenizer was updated with the new token argument. TxtBuf was updated with the new white space check. Project parser. I had to add the forward declaration of TxtBuf. Code snippets, of course, VV project. Yeah, okay, so that all looks good. Everything looks like things I've touched. Line tracking in TxtBuf and relating the lines and tokens is complete, including log context in token. Boom. Nice. Oh, super good. Okay. Okay, next thing. String regular expression patterns. I think I have some ideas around what's happening. We started that last week. I thought we did. We took a look at it. Okay, so \n's pattern was still broken. Blah, blah, blah. I did not record that. Okay, well, the string regex pattern, we're going to need that eventually anyways. And it stresses parts of the system we haven't really stressed yet. So back to test. And mostly what we're interested in isn't even in here. Let's go to main. We're going to look at the output of those. You know what? We should just add some more arguments. That's what we should do. NFA. Put NFA Graph. DFA output, DFA graph. Okay. La la la. Dash n string RB index NFA. Okay. If output NFA, if output DFA. There we go. Now we'll never have to do that again. So our make file. Instead of test, that is fine. We want to regex, which requires that we debug. Okay. We don't want dash O source. We want dash N dash D. Then in the journal we have dot this thing. We need to do that. Actually, I'm confused. This is written source, go up, and do the thing. Dash, oh, dash N dash D we did. Dot. PNG. So we've got NFA dot dot. NFA. DFA. DFA. That should do it. Okay. Turns out you can't forget those semicolons. They seem to be important. This is going to speed up our testing a little bit. Oh, okay. Get this right. Can't open NFA dot dot. Okay, now we're outputting files. Okay, perfect. Now we can look at them any which way we want. Yeah, I forgot about that one. Okay, good. Okay, so now we can iterate a little bit faster over these. Where's the old thing? Let me get where I can show the NFA. If we open with GIMP, paint photos, it's something I can share that'll update reasonably. I can share GIMP. We'll look in GIMP. Things get too cluttered and too zoomed out if I go to full resolution. Okay, open DFA. Okay. So if we go to here and enable GIMP, wherever that is, GIMP, there it is. Boom. There it is. Here is our NFA. Right now we're not doing anything with the string pattern I was talking about. So this all looks good. What we want to do then in our test.WeToke, we're going to add a string. We're going to say keep it, start with a quote, end with a quote. Anything which is not a quote, I think that's the start of the pattern. It's not correct. Rebuild, syntax error. What? And this may be the beginnings of the true problem. Line 22 it said, right? State 17. Yep, that's going to be a problem. Log the table at the same time. Okay. I'll at least be able to look at the table outputs. Let's say date 17. So over here, state 17. Okay, so we expect a character, which is a quote, followed by anything which is not a quote, followed by a character which is a quote. So that's just not being put out to dot correctly, to graph viz. So let's see here. NFA state, NFA states, state label, state ID label. So the problem is here in label. Shoot. This is really only the beginning of our problems anyway. Character toString. It doesn't even ask about escaping. It's starting to get to us here. Better way. Oh, good heavens. So many special cases. All right, so each. Oh. So we have a big to do to actually clean this up. The inclusion outputs are not good, consistent, especially escaped characters and character classes. Yep. dive into this now. This gets complicated. This is probably one of the kludgiest parts. Do I want to tackle this today? Oh, goodness. Okay, well. This is correct. We have a character, which is a quote, go to 18. We have something which is not a quote, and then we have a quote. So that's all fine and dandy. Let's just undo this and comment these out for now. We do need to adjust that technical debt eventually, though. Just gonna log out the tables. Okay, so this is not actually right. We want 0 or more of those. What did I do the inclusion rule? Oh. Okay. I'm going to take a quick restroom break. We'll take a look at that. Be back soon. the initial quote, state 17. If we get a quote, we go to 18. '18 says I 0 or more of these. If I get a quote, come back to 18. If I don't get a quote, I go to 20, which is a character, and then a force to accept. Right, there's nowhere to go. We've got the last character in the chain. So that all looks correct. That's still not correct, because the last part of this puzzle is that it can be either anything that is not a quote or a backslash with a dot. Dot means any character. I think that will blow it up. Not add. I didn't add. Where's a question mark? There's no question mark anywhere. That is a bizarre. No question mark. What is it doing? Take out this character. I just want to see. Okay, so we get a question mark. And either get a question mark where we go to 20, which looks for quote alternate of a not quote or a back. What? Ugh. I think we're getting weird print artifacts because of that same stupid bug. All right, technical debt's killing me. Oh, I think we got to do it. Trying to investigate the string regex pattern, but the conclusion outputs TechDebt is making that analysis difficult. Something priority of fixing the conclusion outputs. Okay. To string. there is a difference between a string and a printable string. Is that what my problem is? Like this is, oops. This is not good. I don't like this. I don't like this, or this, or this, or this one. There are definitely some issues. Which you probably couldn't see because I didn't turn on the. Let's see. Here. This is what I was looking at. It's like these ones aren't good. This one's not good. This one's not good. Plus. Yeah, these aren't good. To C string. Escaped. Oh gosh. Okay. A new function for now. Const char star printable. Yep, there's the C string. NRT space. If escaped. No, yeah, okay. Okay. Yeah, we're allocating 2 bytes extra just in case we need to escape something. So what we're going to look at is byte count equals byte size. Okay. This is a \n or r or t. We're not even weird with space right now. That. Oh no, this is different. Okay. These are simple escape characters. By count plus equals 1 or the backslash. Otherwise, plus 1 for the null character at the end. %NBSP, that is 1, 2, 3, 4, 5, 6 equals 7. Let's print F. A backslash followed by a character into result. And that character is underscore value. And NBSP semicolon, nothing to do there. Otherwise, basically this. I would like end of buffer as an option. If underscore, actually, I'm not sure this actually has that, does it? Oh, it does. Printable. If invalid reason equals end of buffer. Byte count equals 4. EOB, end of buffer. Okay, this, it's this, if it's this, it's that. Needs escaping. Is there anything else that needs escaping? New line, carriage return, tab, quote. Oh, and oh, backslash. There we go. And the backslash needs to be escaped. Okay. Otherwise, byte count. Seven. Let's see, byte count would be 3. Byte size +1. Copy into this result. Buffer contents. Add our offset down to the size. And set that. Return result. Okay, this is part 1. We kind of want this part to be pretty clean, pretty solid. So I need to fake a whole bunch of those UTF-8 values. Hey, JTL. Hey, Javest. Doing good. Doing good. We are trying to address some technical debt today. We were trying to debug something else, and the technical debt is just killing it. So there we go. It always comes back to bite you eventually. So basically we need a nice printable, clean way of looking at things so we don't look at some of these labels are really bad. So we're trying to fix that here. We have end of buffer, non-breaking space. We're going to try this. To test. To test. We're going to cheat. Are we? Oh gosh. You know what? We can cheat. This is... Can we cheat? Well, let's just build up one piece at a time. Printable length. Result equals 0. Return 4. Well. Result equals 7. Result equals 3. 2. And 6. And 3. Good heavens. Where are we going? Otherwise, result equals byte size. Up here, this is good because result always equals a new character of size printable length plus 1, simplifying our code. There we go, bit of clean up here. Okay. So I have printable length. Pardon me. Oh, something in the air, I guess. Okay, now inclusion rule. Let's just make a new function for that. Just like we were string length. Printable and printable length. Right after string length. Basically, this part of the code we kind of grew as we thought we needed things for getting output, and never really was carefully built up. So when we create these character strings, they don't really get formatted very well. So we gotta do that now. We're gonna build it up. So one, see here. Result, return result. Sure. Make sure the thing we are doing is valid. We ask ourselves, result plus equals our start character dot printable length. If this is a range, result plus equals end character dot printable length plus 1 for the hyphen. I'm closing this in square brackets. Probably. Oh, no, we should not. Okay. I think that's it. This is much simpler this way. Much better. Therefore, result equals new character array of size int printable length plus 1. And we might as well do this. if this is valid, I think I want to just make this as simple myself as possible right now. If it is range, otherwise, sprintf into the result. Equals the start character dot printable. One temp two end character printable modulus s through modulus s. And turn the result. And these are backwards, of course. There we go. If it's arranged, get both of the printable things and stuff in there and call it good. Okay. Now, inclusion set. Inclusion rule dot just want these to print out nicely. 2 strings. See how complicated that is? I think. This will simplify things a lot. So what do we do here? We tally up a length, which I'm fine with. Oops. We do that here. For each inclusion rule, in the rules, oh, that's one thing we do want. Oh, wait. Dot. Dot is any. I'll have to think about dot. Just a moment. Okay. Rule equals no pointer, rule length equals 4. Interesting. Maybe we can have a null in there. It would be a visual indicator when things are wrong. Return the result. We have to revisit this in a little bit, but that's fine. Inclusion set, we'll get the result length, etc. Up here, so here's the deal. Oh. Rules.size greater than 1. Or, let's just keep it simple. Length plus equals 2. Else if rules.size flip this. If rules.size is 0, length will be empty5 6 well 5. Else if rules.size equals 1, we have to check. Pardon me. If rule 0 is not a range, okay. Rules.size equals 0. This is easy. Result, that's your S print result empty done. Neat brackets equals false. This is actually probably better. If the size is 1 and rules is a range, then needs brackets. It's true. If rules dot size is greater than 1, needs brackets is true. Okay. Seven. Needs brackets. Rule count equals rules dot size. Okay. If we need brackets, length plus equals 2, and we're done. Okay. Rules are that, then we just output empty. That's easy. Oh, and also, let's see here. Isn't there a Boolean somewhere? Bool. Okay, I guess we don't do this here. I think we do. Kind of. Who keeps the, let's see here, NFA. Oh. Okay, so the NFA knows if it's in or exclusive. It has one inclusion set. Okay. No, we're just gonna skip that. We're not in brackets. Empty. Otherwise, we have an offset, a temporary string, basically this, I think. For each ruling rules, if the rule is null, okay, I remember what this is all about again. Rule to string to printable. Okay. Which TD, what languages are you using as inspiration? Oh, nice. You got the HTML done for the first project? Cool. Yes, weekend time. Nice. Always good to get the base HTML done. So what language are we using as inspiration? Right now, we're not at the language development part. We're way before that. Oh, well, did you already leave? Or are you still there? The we're not developing a language just yet. We're early stages. So when you're building a compiler, there are several stages. One of them is the tokenizer, where you take a block of text, break it up into tokens, which is like reading English, right? We got to have the syntax, the punctuation, the words, break it up into pieces of meaning, right? Then the next stage is the parser, which takes all those symbols and gives them structure. Like in English, we have a subject, noun, verb, adjective, adverbs, how the sentence is put together. That's kind of what the parser does. We're not there yet. Once you have that, it has a structure, and you can analyze that structure for errors and for meaning, which is your semantic analysis. So we are even before the tokenizer stage. Writing a tokenizer is not trivial, it's simple enough. It's basically a for loop iterating over the characters of your text buffer, and you're trying to, depending on what character you see, you go to a different state, right? So if I see an integer value, or a digit, I go to the parse numbers function, right? And it'll munch through all the characters until it finds something that it's not a part of the integer, and then it returns the integer as a token, right? So it's actually not hard to write a tokenizer, but a tokenizer generator takes patterns, like maybe something like this, and given this regular expression, it will generate for me the tokenizer. This isn't always a good idea to use a tokenizer generator, but it's it's fun. It's my project, so I do it the way I want. The language will probably be somewhat C-like. I just want to explore some different ideas with flow control, more on the structured programming side of things. I don't know that I plan on taking it all the way to being a useful language just yet. The more languages you build, the better you get at it. So write some throwaway ones, write some experimental ones. See where we're at. We are building up a lot of tools. If we get the tokenizer generator and the parser generator done, we'll be able to explore different ideas. In the meantime, we're working in C++ with a strong C bent in a lot of ways. So hopefully you're still here and heard the answer, and if not, I'm sorry. I sometimes get caught up in my coding, so we shall see. Pattern log the tree. Take the pattern. Okay. Watch how logging goes. There we go. Okay, let's try this. Give me the printable length. I don't even need to print it, do I? In theory. operation and then the value. Okay. Let's compile and just see where we get clean. Okay, okay. I know what some of these are already. Assignment inside of a conditional, always bad. Copy paste in for fun. We did not update the pattern. 1, 2. Oh yeah, rules.size. Did we do that twice? We did. And that should just about do it. All right. So let's take this string out for now. Let's see if this prints better. Core note. Ah, shoot. Why would it do that? I don't suppose there's any way to catch that inside the debugger. Okay, don't stack trace. Oh, gee, I doubt it's going to help. Yeah, it blows away the whole stack. So whatever we're doing wrong is terrible. Okay. Printable length. Characters. Byte size. Backslash and a character. Those are string copy to result. Result. Oops. Aha. Result equals no. Yeah, we got the order there backwards. Why don't we transpose those lines? That's no good. Oh, still failing. Yeah, still no trace. This is deep enough in the code that I really don't have a good place to put. Oh, well. To string. This is the table output. Printable. still failing. Still no stack. Not my favorite. Huh. And if we put it back, does it work? It does. So go to breakpoint 155. Oh, that could be a reason right there. Okay. And then toString. Hey, that's better. Okay. \n, \r. What is this? Oh, that's DM. Hey, okay. So it should be printable. There's the NBSP. \\. Not like a \t or a space. Oh. See, this \/ whatever is not quite right. So the printable okay. No, 2. It's still 2. But I am yeah, we're copying the actual thing in there. So as print otherwise \n. Okay. R. T. Quote. And backslash. You know what? All these sprintfs could be stir copies. It's probably more efficient anyways. Those are all string literals, so it shouldn't be too bad. Okay, so we come back up here, much closer. \t NBSP. I don't see the space, so that's interesting. One or more alternate // \n \r. Okay, most of these are looking pretty good. This this is a lot more readable, except I don't know where the space went and why the width of this column is not right. Oh. Printable length. For each rule, get the rule length. Make it printable length. Add it in, return it. So that's not rocket science. Rule. The length of a printable length. Oh yeah, which is this. And +1 for the hyphen. So that should be fine. Printable length. End of buffer, it's 3. End of buffer. 100% NBSP. Escaped characters. Result equals the size of our bytes. Okay. All that looks right to me. So NFA, let's get this printing right. We get our length. And if the length is greater than our column width, we widen out that column width. If column width is less than 5, which is this, make it 5. Okay. 0, 1, 2, 3 plus 1, interesting. 4. Okay. And yet this string doesn't look right to me. Table. Let's go to it's fine, doesn't matter. It's length. Let's just see what it's reporting. Column for width. Oh, maybe that's a problem. Therefore, the column for width would be 5. That is correct. That's okay. Result equals 0. Oh. Would it help if we did the right thing? That's better. \t, non-breaking space. I don't see the space itself. So that's unfortunate, but all of these are quite readable. Better than they were. So, where did the space go? Where did the space go? One fun thing we could do printable. Do handle character classes nicely. \s is a pretty typical one. \d. Should probably be inclusion rule. Reset character classes. Just an idea to work on later. Okay, so really there's only one, which is the UTF-8 character reference, where we get the printable length. If value equals a space, space UTF-8 charref dot total length is of space. Printable of space. Okay, so that should fix up table printing pretty nicely. Space 1, space 1, space 1. It returns a backslash? Wow. What's that, a backslash? Printable ASCII characters. Space. If it's between space and tilde. Space less than or equal to value and value is less than or equal to tilde. Result equals value. So we've already set the length here. Set the null terminator. Why do a stir and copy if we know it's a 1 byte value in the printable range? There we go. Now there's a space. It's a little odd, but we can work with that for now. Okay. Inclusion rule. There we go. If it is a range, we do that. If start C equals 0 and end character equals 9. Oh. Plus equals 2 or backslash D. Otherwise, what other ones are there? Backslash D is pretty straightforward. This is a range. If it's this, to result backslash d. I don't think that's in my test token. Int, which we'll keep, which is an integer plus. Inclusion rule handles that. Let's just take that for test drive. There's a backslash D right there. Perfect. Okay, last one. This white space has to happen at the inclusion set. Let's add a small private member here. Private is digit. Let's make this a little bit more generally usable as a pattern of usage. Return is +2 for the hyphen. Whether it's a digit or not. Okay. So inclusion set is a helper function called is white space. Our goal is to make everything print out as nicely as we can. Actually debug things easier. All right. Result equals false. If rules dot size equals 3. Tool has space, has tab, has and BSP. For auto rule in rules. If not, rule dot is range. And rule dot start C equals space equals true and break. Not break. We don't have the break. Else if rule start C equals a tab. Tab equals true. Else if rule dot start C equals. Oh, where did we do this? UT F8 character reference. This number. As NBSP equals true. Else break. So this contains anything that is not those three characters. It's not. Then at the end of the for loop, result equals has a space and has tab and has a breaking space. Okay, part one. Now, printable length. If is whitespace. We do one thing, otherwise we do something else. Result equals 2 for that. Then in printable, if we is whitespace. If it's whitespace, we do one thing. Let's do it this way. Stir copy. Stir copy. There we go. Let's see how that turns out. Oh, it's digit. Oh, interesting. It should definitely be const. So should this one. All right, we're getting close. Oh, yeah, this is a function call. Oh, compilation. Hey, there's our \s. Okay, so this is all very nice and printable and readable and understandable. That all makes sense, except what happened here? Oh. These are 2-byte characters, so there are 2 bytes when we compute this string length. I could live with that for now. I kind of don't care. That's fine. Oh no, printable length. We could actually be smart about this. We could fix this. This is one thing. Printable visible length. Result equals printable length. Kind of. It's not quite, because here in this else, it's 1. No, let's not screw around with this. Okay. So I'm going to call that partial fix NFA log tree state log. Okay, so NFA state to string. There it is. Inclusion point to printable. I guess it can be consistent here. Can be. Okay, if character inclusion or exclusion, we want them quoted. Okay, okay. Okay. Make a change here. Let's put this here and is digit. I'll be able to ask the question at this level and pass the logic down if you want to. Actually, you can simplify this a lot. Return rule size equals 1 and rules, the first one, dot is digit. Easy. voice date dot result. If conclusion point to is digit, result equals conclusion to string. Conclusion is whitespace. Otherwise, we do the fancy schmancy brackets. We're basically suppressing the need for brackets. Same for exclusion. No, exclusion always needs those brackets. Rules. Oh, let's see conclusions and P. Type is rules. Is it a list? Oh. Okay, let's see. I just want the first item or the last item. It doesn't really matter, whichever is easiest. Clear, insert, push back, and place back. Up. I want the first thing. That's why I used the list. What? I get the first thing. Begin, end. I don't want to iterate. Size. Insert and place. Erase. I don't want to. Pop front, pop back. Why is there no like? Oh, front. Access first element. There it is. Whew. Did not see that for a while. Okay. 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 Stir. Some games. Oh, for Pete's sake. This thing returns a constant char star, but the result. Okay, here's what we're doing then. Result of the const. Oh, constness. Temporary string equals inclusion printable length plus 3. And we write to temp string the printable result equals temp string. Delete temp string, delete printable. Okay. Okay. Printable equals this thing. Temp string equals printable length plus 4. Yes. Hello? What? Okay. Ugh. Well, that's... Oh, yeah. Temp string. Result equals temp string. Oops. Minor failure on my part. We'll figure it out eventually. Are you free? Oh. Yeah. Okay. Phew. That table, or this, oh. Let's print the other thing. Just make sure it looks about right. Log tree. What? Log tree. Not constant. Because it cannot be. Because we have to clear out visited and keep track of who we visited and who we haven't. Dang it. That's awkward. I thought there was a keyword for something. Mutable? Mutable. Mutable, I think is the word I'm looking for. Now maybe we can make it const as well as now maybe log tree can be const as well. Clear visited. Oh, here we are. Okay. Oh, come on. full clean. I don't think this view is as good as the table view. Does work. Alternate, 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 0 or 1. Oh, look, there's our \d. There's our \s. Right there. Perfect. So everything's printing out nicely now in these two logs. Last piece. NFA. Export graph is. Label. State label. Oof. Oh, okay. This is exactly what I want, I think. So maybe it's fine. Oh, wow. Okay. Back into it. Hey, Daiko Kurdo, welcome back. Compiler is progressing slowly. We fixed the line tracking with our text buffer. So we can correctly report lines of text now with the token indicated and keep track of all that, so that's nice. 10-hour study session. Yuck. Chemistry? I know you're not a chemist, but that's a lot of studying. I'm so glad I'm not in school anymore. Now we're trying to fix all of the things to log out nice, neatly, and readably, and it's not working, so close. Hey, C Films, how's it going? I'm doing good, doing good. Welcome to the chat. Chemistry's hobby. Get into med school, okay. Yeah, med school is ambitious. So, what's new, C Films? Welcome aboard. You've joined us at an excellent time. We're just having fun. Trying to print occlusion length. So that's in NFA. Yeah, this log. And that log. Okay. So compute all of that. Then we build this table up of all the NFA parse states, and those are readable. Good, good. Yeah, so you're gonna be studying for a long time, Gyako Kurdo. What are you trying to compile? Right now, we're very early stages. No specific language defined. There is LLVM. No, so what we're trying to do is build the entire compiler from scratch, no dependencies, no nothing. And we're doing it in the not optimal way. We're doing it the fun way. We're doing it the way I want to do it. So right now we're in the Tokenizer Generator phase, right? So the first stage of a compiler is to tokenize a block of text into meaningful pieces, right? So your semicolons, your parentheses, your variable names, your type names, keywords, so forth and so on. Break those out into individual tokens. Then, and that's not even that hard, right? If you just take a block of text and you iterate through every character and you're just like, hey, is this an integer? Then eventually you'll call a function that says, hey, this is probably an integer. And then when you see a decimal inside there, you're like, oh, this is actually a float, unless you hit something that's not a decimal digit or a decimal. So you can actually write your own tokenizer pretty easily. So we're writing instead a tokenizer generator where we feed it some patterns. So like test.vtoken. So here are some regular expression patterns. Here are the actions to take when you find one. And here is the token ID that, this is an integer, this is a comment. And from here, it will build out something that looks like this. And it's a mess, and I know that's because of some other goals we have. So it generates your tokenizer from there. So once you have, is this for a new coding language? Okay, yes, this is for a new coding language, but one that isn't designed at all yet, right? We're going to get through the Tokenizer Generator, which will generate our tokenizer for us. Then we'll build the parser generator. I have no unique or interesting ideas about parser generators. We'll probably just use an LALR parser generator. Then we'll do the semantic analysis, which is where you actually design your language, right? And then we'll start designing language. The language will probably be pretty C-like, and I'm just going to be playing with some language flow constructs, looping things that I wish other languages had. Want to see how hard it is to put it in there. Once we have that all done, I don't know what backend to use. Maybe we'll generate C, maybe we'll generate some LLVM, maybe we'll generate, WASM, NASM, FASM. There's so many assembly languages to choose. Ideally, eventually, and maybe we'll do all of them, right? Maybe we'll do interpreted. We're just playing around. But eventually I think I want to generate the Windows executable from raw binary itself by myself using the Intel x86 64 specification. But that's all long ways down the road. We do compilers one day a week, so progress is slow. This is more of my break up my tasks a bit. You like films, see films. That makes sense given your username. So what kinds of films? I tend more towards older films. I think there's a lot more artistic merit in older films. I think modern films have too much message they want to spread and have forgotten how to tell a good story. A lot of them. Maybe not all, but certainly enough to make most modern films not interesting to me. Yeah, if you want to talk films, we'll talk films. That's not a problem. It was a little bit random, but you've been trying to make a new coding language, and what's your goal with that coding language? What does it look like? Or what's your tool set? Like, I don't know, I'm just interested in other people's projects too. Everybody has different approaches. A knowledge and enthusiast on movies and TV. Okay, all right. So, greatest movie of all time. What is it? Gone with Compiler. Gone with the Wind was a bit of a slog, I'm not gonna lie. It takes an awful long time. But wasn't that the first? The OOP father. Compiled in 60 seconds. The Tokenizer and I. First rule of my favorite movie is you do not talk about it. Okay, all right. I won't talk about it then. A little Brad Pitt and Ed Norton action. Okay, all right. Interesting, interesting. Where was I? NFA. So I have a problem I want to debug, but these printouts of the patterns were so bad that I couldn't actually tell what it was I was reading in certain ways. In certain ways that mattered. So ideally, we get this all cleaned up. I know these are working. NFA export graph viz. Yes, I got the reference. I got the reference. We made jokes about not talking about the first rules of things all for a long time. New coding language is called McFly. Okay, interesting. You have a repo for it or something? Or a top level description? What do you got? Functional, OOP. So Fight Club over Princess Bride, huh? Shame, shame. So I guess I've got a few favorites depending on what you're looking for. I love Princess Bride, excellent movie. I'll take the original Star Wars trilogy pre-special edition. I will take Life is Beautiful, but you can only really watch that one about once a year. Christmas Carol, starring George C. Scott. Watch that once a year. That's the after Thanksgiving dinner kick off the Christmas season for me. Required mandatory viewing. And probably Hobson's Choice. Hobson's Choice is an old black and white film. Very good. Well written. If you want more comedy, I would go with What's Up, Doc? Or It's a Mad, 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 Mad World. Its slogan is it learns from the past but looks to the future. Okay. You've seen Turtles Can Fly? Kurdish film? I have not seen it. Turtles Can Fly. Interesting. It has a Wikipedia page. I guess that's a good start. Okay, okay. Ooh. Also for comedy, Oscar, starring Sylvester Stallone. Very good. Okay, so I've got the Wikipedia article up for Turtles Can Fly, war drama film. Okay, all right. I've got that one. The People Under the Stairs. All right, I got that one open. Oh, you're more into the comedy horror. There you go. All the movie you'll ever need. Yeah, whenever you have a war drama film set in yeah, it's probably very sad. Okay, all right. People are It's like The Burbs. Okay. Yeah. Reminiscent at least. Okay, okay. So yeah, see, Films, let's hear more about your programming language. I'm always curious what features people are drawn to. Me, I think there are some very, very basic, simple language constructs, like just looping, branching constructs that don't exist and I think should exist. But we're nowhere near that. It's going to take me years at this rate, once a week. It's about a boy called Mr. Satellite who installs a satellite dish for a village during the US invasion of Iraq. Yeah, that sounds pretty intense. Pretty intense. Why would this crash? Label doesn't seem that dangerous to me. Were we using that? Not using it anywhere. So what is this label? Okay. Character. Inclusion, exclusion. These are special. I don't actually want the label. Let's see here. How many backslashes does one need? 1, 2. And around a character. Equals new character of inclusion. Printable plus 2 plus 3. That's printf backslash 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 quote 1 2 3 quote. Oh, 5 backslash quote backslash quote and one for the okay. Printable result equals temp string delete printable. Oh, result equals temp string. Therefore, we almost never delete temp string. That may be part of the problem. Oh, let's see here. The McFly repo. Okay, okay. I'm always interested. Double interpretation, interperception. Deception's pretty good. The Dark Knight is quite excellent. I cannot lie. It's quite good. Oh, Pat. It's in C++, the AI. Yeah. How is that going, Pat? I know you've been busy lately, but your AI language applies a statistics and math focused coding language. So more like R, or maybe like a Julia, or I guess Python with NumPy, SciPy kind of thing, or like Octave or MATLAB. Lots of options. Let's take a look. We're using Python. Calculations based on the order of operations. Compare numbers. Quoted string of text. Okay. Okay. Plus minus multiply divide equals equals. Oh, okay. Greater than less than equals not equals. Okay. Boolean operations. I approve the use of English words for logical Boolean operations. Good, good. String constants. Okay. Cool. Python 3. Oh, nice. Python with 5 Cool. So you actually are doing this all single file and no dependencies. Nice. I approve. So you're, oh gosh, 1,500 lines deep. Lexer. Cool, cool. And you're actually importing very little. Nice. Cool. It's incredibly bloated right now. Lots of things still need refactoring. Yep. I moved a lot of things off the heap that didn't need to be there, and there are a lot of duplicated codes that still needs to be consolidated. Yep, yep. Adding new features almost seems impossible for the AI at the moment, Pat. Like structs, classes, etc. Yep. Okay, all right. Yeah, it takes a lot of coaching to get the AI to output what you want. Warning. Oh. That would be a terrible thing to do. Doesn't even make sense. File written. Okay, last piece. What else here? NFA dot. I somehow doubt. Oh. So these escaped characters here need to be doubly escaped. But backslash D backslash S are showing up. All right. Now's the part where things get tricksy. What do I think of the McFly coding language? Yes, it is a good start. You have. I like that you're not using any libraries or dependencies. Like, people start throwing things together from existing pieces without ever understanding what they do. You build it once yourself, then if you want to use libraries and whatnot, great. At least you know what choices there are to make and what the trade-offs are. So generating tokens, yeah, this looks pretty good. As a starting point for sure. Generate, yep. You'll find that Python, if you're looking for high speed, is probably not the best if you're going to be processing large files. Python doesn't loop well. You may end up writing parts of your tokenizer parser into something else, like C, and then loading that up from Python. But I mean, I'm not going to knock it. Like, Python is a great language for thinking in. The stuff I'm writing now, I wrote first in Python ages ago when I was exploring the ideas. Okay, so here's the question. I need to be able to ask for a further escaped version. Else if ooh, oh man, oh man. If escaped. What we're doing is throwing in the extra backslash or when it's resolved. So I think that's that. So 1, 2, 3. Is that the right number? I think. It's currently like the REPL sits on top of Python. Yep. Hey, Javest. Thanks for dropping in. Have a wonderful weekend. See you on Monday. Let's see here. I'm trying to remember. There was a project once. Norvig list in Python. Yeah, this here you go. Boom. It's a Lisp version of that's built on Python. Norvig is an excellent, and really it's like what is that? Maybe 50 lines of code. I'm not saying that like Lisp is a Yeah. So anyway, super cool little project. If you want to do it on like a weekend, it's fun to play with. Full listing posted at the bottom. I was finding it interesting. I worked through it once. //n //. Okay, I think that's it. So in exclusion rule, goodness gracious, no regrets. There we go. Okay. Escaped. Escape. Just pass it through. It's really not that complicated. Oh, geez. Except is digit. Okay, all right. This is escaped. Result plus equals another one. So we can do another backslash. Okay. So length escaped, escaped, escaped. If is digit, if escaped, inclusion set. Okay, if is escaped. Okay, so run that. And that doesn't fix the issue yet. Because when we go to NFA state label, everywhere we have printable needs to be true. So we do this printable true. And everywhere we have printable length Okay. Main coding language inspiration is PHP. My coding language inspiration, I don't know. I've made a lot of like special purpose scripting languages, interpreted bytecode interpreted languages over the years. Declarative. Um, I've written procedural. Not really got into the object-oriented programming languages as an I'm building it kind of thing. Mostly I want to look at the interface between the programming language and like assembly level code. So more low level. Okay. I'm going to pause briefly to use the restroom. I shall return shortly. Just a moment. Will your Boolean operators be words, symbols, mixed, or both? So for me, I like the C-style symbols for bitwise operators. Just the single pipe, the single tilde, that sort of thing. But for logical Boolean operators, I definitely prefer words. So there will be and or not in words like Python. But I want multiple return values. Thank you. Okay, let's change up the makefile just to Scoj here. I don't need this yet. And then we're going to look at nfa.dot to see what we're outputting again. I think we need those. I don't want those there, actually. I've decided. Now in nfa.dot. \n a quoted new line. Oh, good. Question mark. Okay, so there's a question here for me. Let's just try it, I guess. Oh, it worked. Okay, let's take a look at the file. Is it more readable? I see, I see. Okay, so let me open this in a thing you can see. Open with GIMP. Okay, now I share the GIMP. Where that is, there's GIMP. Okay, so alternator, star, text. All of this looks about right. \d, \s, those all came in good. If we're matching a character, it's in quotes. So same with a // anything which is not a new line character. Hash, anything not a new line character. We're really just creating patterns. Like, this is not language defined yet. We can have a new line character or carriage return, which may or may not be followed by a single new line character. Carriage return line CRLF, carriage return line feed. Basically, Linux does \n. Mac used to do \r, and modern Windows used to use \r \n. So you can end up with line endings of all three kinds. \s is whitespace. Yeah, this is way more readable. Thing. Okay. Not bad so far. So let's put in the thing. Will the coding language be more like assembly or assembly 86? No, it'll probably be closer to C. I think C is just about, it's about as good a language as you can get for anything. except for a few weaknesses. Yeah, I like generating assembly. I don't like writing assembly. But C gives me all the control over everything. I can do anything I want. It does not babysit me. I shoot myself in the foot all the time. And that makes you a better programmer, I think. You have to understand what the machine is doing with your code. Now, for a lot of tasks, I do use Python by choice. It's like, yeah, that's just easier in Python. Or I'm learning this idea, I'm going to use Python for it because the distance from symbol to idea working is pretty small. It's a low friction getting things started. Performance is tough in Python though. McFly is not OOP. Okay. I mean, OOP. OOP is just another tool. I can do OOP in C. I don't need a language to do it for me. It's just about knowing when to use which tool. That's what I think. Sometimes you program things in a functional manner. Sometimes you program them in an object-oriented manner. It depends on what your requirements are. Unfortunately, it depends a lot on what your team is doing and what requirements are put on you by your coding standards at the company, blah, 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 blah. Not as much fun. But OOP is just another tool. Often misused. A lot of people get very religious about this is the best way to program. It's like, well, for certain classes of problems, yes. Right, string, we're going to keep the string quote. Anything which is not a quote followed by a quote. Now this is not right. All we want to do is see how the picture changes. Actually, let's build a line out of makefile. I want to generate. Oh wait. We need to do this and this. Oh, yeah. Once I put quotes in, it gets messy. So if a dot dot line 22, a quote, a quoted quote. Oh. Okay, so we didn't quote. We need to further back. Oh, wait, what? What did that just output? Backslash quote, backslash, and then a bare quote. So we need one more escape right there. I'll bet that works. And there. Okay, then if we reload this in GIMP, then I share the GIMP window. Oh, that's awkward. Okay. Here's a quote. A quote followed by garbage, followed by another quote. So we're missing some quotes in our output. Almost there. We're so close to being able to actually read and understand what's going on. We need to add one more character if it's a quote for reasons. If value equals quote, result plus equals another one. then here, we get a quote. We need one more backslash in there. So many backslashes. All right, run it. We wrote the dot file, and in theory, that's done as well. So, reopening our image in GIMP, and sharing GIMP. In McFly, I want all string variable names to start with a $sign. Oh, thank you. Yes, my nose has been, my allergies or something, I don't know. Been going today. Okay, so a prefix $sign, so that's kind of a PHP bash-ish type of thing. Okay. So you're going to need a dictionary of variables. Okay, that printed correctly, that printed correctly, that printed correctly. Okay. Whew, finally. I think this is readable. I mean, maybe not on small screen. Oh, I didn't click the button? How did I not click the button? Goodness, okay. So state 20, we can get a quote, not a quote, and then a quote. Okay, so that's part one of what we're trying to do here. So if I go to here, okay, this is not quite right. It needs to be either a quote or a backslash followed by anything. This is the part where I'm not sure. Oops. Oh, we're not doing that. You have to update the DFA to use the new logging stuff and debug. And it dumps out. Good gravy. I think I know why, but I don't like it. Want all number variable names to start with a, okay. $sign string, hash for numbers. Anything else? What other types? So you're declaring your variable type by the name prefix, and then it's always part of it. Hey, XTedious, thanks for the follow. Welcome to the stream. Hopefully you're having fun. We're just messing around with NFAs and DFAs. We are cleaning up some old technical debt because we were trying to fix the string regular expression pattern. We kept getting bit by the fact that we couldn't actually read our outputs very well. So, trying to eat up some of that technical debt. Ooh, by the way, folks, I'm really bad at, I should write a bot or something. I do have a Discord channel if you're interested in knowing when I go online. Fridays is compiler days, Monday through Thursday is game engine with 4 dependencies. No game engine and only the 4. So yeah, feel free to jump in the Discord channel. It's pretty quiet in there except for the stream announcements, but you know, feel free to post questions, comments, anything you want. Yeah, so welcome. Thanks for the follow. Now what? Where was I? This one. Okay. So I may be getting ahead of myself in here. Let's get the DFA working. The DFA, because I don't think the DFA is up to snuff with the new stuff, and I would like to delete the old stuff if we can. DFA cpp log. Okay, the states log themselves. Export graph viz. Oh, the transition gets its own label. Where does the transition get its label from? DFA state. Oh no! Okay. What is in my log? The transition logs itself. Operator names, state IDs, rule IDs, token IDs. This doesn't actually do much except, oh, okay. The start or end of line. Okay. String. I think what we can do is this readable, and that's it. I think that's all that needs to be done there. And kind of the same thing here. Like interface states label. So if it's an inclusion, oh, no, these need to be true. Yep. For the exclusion, I think this. Okay. Main. Make sure the DFA is putting all the new stuff. Okay. So with the $sign and the hash, that's kind of like having a built-in mandatory, what was it called? Something prefix. What was that? I see. Fusion to fusion dot. Then I really want to delete all the old string stuff, but instead of dash n, we want dash b for now. DFA, DFA. Oh, it worked. Okay, so let's look at this. Backslash NR, the S came out nicely, the D as well, good. Backslash N, backslash S, forward slash. So that's the second forward slash, backslash N, backslash R. Neither of those, okay. I see exclusion D, or inclusion D. Yeah, so that all seems to be working okay. And then let's take a look at the DFA image. Oops. Which I have to share on OBS. There we go. Boom. Okay, this is all quite reasonably readable. Why is that in brackets? Oh, that one. That one makes sense. I don't like these brackets in here. I don't remember the brackets being in here. Yeah, they're not. So what are they doing in here? Let's do with where DFA is up. Stuff, I bet. Alright, let's go hunt down those extra brackets and get rid of them. We want things clean, we want things readable. Boom, and DFA state. Exclusion always gets the brackets because it has to, but this one does not. Set. We need to ask one more question. Is character, is it a match on a single character? It's actually quite simple. I'm going to put that below is digit. Typing brackets is legal day is hard. Okay. All we care about is that there's one rule, and that rule is not a range. Then DFA state. Oops, on this one. If inclusion set is character. We'll do one thing, otherwise we'll do the old thing. Oh, we don't need to do that. We can just take result equals the printable. Single character. Oh, no. Also +3. not sure I can do that because we're doing the extra escape anyway. So let's just try result equals interval. Let's see how it looks. Boom. This thing still looks good. Sure, etc., etc. Yep. Now into GIMP. With our DFA, and I think I'm happier with that already. So let's bring up GIMP. Basically, I'm sick and tired of not being happy with being able to read this graph easily. So \n, syntax characters fine, \n, \r, \s, good. // anything that is not a new line character. / anything that's not an end of line character. \d. So any number of digits plus 1. Identifier, identifier, identifier. Okay. Okay, so I'm happy now, finally, with what we can output. Which means we can go back to debugging our issue. I think we should be able to see what's going on in our issue now. So, journal. Oh, we need to do a cleanup. To string. Let's say it's down. Okay, well, whatever. Okay. Binary file, I don't care about. So, DFA state. All of the two strings, I believe, are gone. NFA state, similar issue. Those old two strings were ugly. They never should have made it out the door like that. But, you know, early in the project, you do what you need to do to get things started. NFA to DFA converter, solution to string. Is that only when I'm... Yeah, this is the part where things get interesting. Let's check NFA to DFA converter. Log. I think I want printable. think it's just going to always work better to do it this way. iData. What was iData? It's inclusion set, yeah. No, I want to. I know what these all are. I know what they do. It's all commented out anyways, so low risk. Okay. Now, no inclusion set is actually using that. I suspect okay. Don't care about binary files. String length is the other thing we want to get rid of. To string. To C string is the characters. I don't think I actually want that. Oh, cleanup is bare. Okay. Seclusion rule. This is actually manageable, so we don't need to do anything like that again. Oh, that's not what I wanted. Okay. Yeah. Got to remove those files. -rf star temp star text. Okay. Now when we grab, all we get are these ones. Good. So inclusion set.h. There we go. Okay, now let's get out of down string length. Good, good, they're gone. Now, to C string, NFA to DFA converter, pattern to NFA converter, and VV project. Oof. Oof. Okay, yeah, this is so much better right there. Boom. Look at how much simpler that is. UTF-8 pass. Pattern to NFA converter. If these are like in logging, then yeah. Double. It should just be in UTF-8 now. Bad code, bad code, bad code. Good. Okay. Hope that all builds and runs as before. Oh, okay, all right. We are so close. That was shocking. Not that bad of a removal. Type string. And then delete. Yeah, so we make this const. Easy. Let's run our little test as well. And with all that working, our other make rule should work fine. So go to our shell source builds debug. VB test parser. It does, it still works. So we didn't break anything there. Dash N dash D. And those should now, two lines should work. So clean and regex. Oh, it felt so good to get that technical debt off. That one I was dreading. It wrote the file, it wrote the file. Might as well do this, right? There are times when it's easier just to go look at it on the console. Oh, so good. Search our DFA. It looks readable, nothing weird or wonky. And this one looks okay. Okay. Mission accomplished. I guess the last thing is to look at those two images that were just generated. So we'll do that little manual inspection. Okay, so here's the NFA. Everything sort of looks about like I would expect. You can tell that the question mark, plus, and multiply are not character matches because they're not in quotes. Good, good, good. Oh, thank goodness. That's good. And then the DFA similarly looks readable finally. Right. Good enough. That technical debt had been looming over my head for a long time. Inclusion. Let's see here. Updates for better output of UTF-8 character reference, inclusion rule, inclusion set, and thusly, and thus, NFA and DFA logging and graph viz outputs. So much better. Yeah, we touched a bunch of stuff. Add everything. I don't see anything in here I need to remove. Yep. Looks about like what we touched. Cleaned up. Char ref and inclusion string methods. Much more readable everywhere. Okay. Whew. Which brings us back to fixing the thing, fixing the string regular expression pattern. Now that regex is getting big and harder to trace through, so what I want to do let's simplify. Let's go to TxtBuf Tokenizer, mini vtoke, and all I want is this rule: string keep quote. Anything which is not a quote, followed by a quote. Okay. What? Oh. My bad. Makefile. Mini. Should be a much smaller thing. Oh. Okay, fine. Test goes back in. But then test.vdp needs to point to mini vtalk. That's what I meant. Okay, so the NFA still hates it. Ugh. We get a quote, we get anything that is not a quote, we get anything that is a quote. And this one accepts. So the NFA looks about right. The DFA, we get a quote, get 1, and then if we get something that's not a quote, we go to 2 to there. So DFA, NFA, NFA dot file. Line 2, right there. Well, shoot. That literally just stuck the pattern itself in here. Okay, so NFA export graph is where's temp? We don't need, let's see here, temp. Oops. We're not putting a pattern in there because I don't want to do it. NFA. That should help. Similar issue in the DFA. Where do we get that pattern from? Okay, that looks more promising. And that file should be very easy to look at. It should be trivial to understand. OBS, here we are. So DFA, state 0, match a quote. Oh, for Pete's sake. Go to state 1. State 1, don't match anything that is not a quote. Why are there quotes around that? Or that, for that matter? Oh, because they're matching. But this one shouldn't. Exclusion. So the NFA, yeah, that doesn't have strings around it. So we'll clean up the DFA real quick. Oops, no. Okay. Exclusion. Where's that extra quote getting put in? Label. Oh. Okay. Reopen those. Take a look. There we go. Anything that is a quote, followed by anything that is not a quote, followed by a quote, and accept. Quote, not quote, quote. Why are these ones in quotes? Oh, because it's a character match. Okay. We actually probably should match that. That is my instinct, is try to at least be consistent, right? If transition inclusion is a character, so close. Syntax error. Line 12. Anything which is not an escaped quote. Oh, we not. What? One, two, three, an escaped quote. Wait a second. Escaped quote. There we go. That's better. Now let's see if those load up. Oh, I think I know what this is. Okay, so let's pop up this thing. Still putting quotes around this thing, even though it's. That's because the exclusion hasn't been updated. The code to match the others, so that's easy and quick in theory. Okay, is char cares about whether it's an exclusion or not? Here we don't care. Transition op equals give a state operation. Inclusion okay. One more try. The more consistent you are, the faster or easier it is to see what's going on to debug. In theory. Boom. Okay. Quoted character, unquoted brackets, quoted character, unquoted brackets, quoted character. Perfect. They're consistent. Finally. Minor consistency pass for DFA versus NFA outputs. Consistency pass for NFA, DFA outputs. Okay. Which is good. Now, back to debugging. Mini. Or backslash quote so here and this thing. Oh my, let's see here. NFA, match a character, then either match not a character followed by a quote, or we go to 4 where we match a backslash, which goes to 5, which matches a quote, which goes to 3. Backslash quote quote. That looks correct. Match a quote. We match another quote. Oh, anything that's not a quote, go to 2. We match a quote going to 4. Backslash 3. Quote to 2 to 4, yes. Or we can get a backslash 3 to 2 to 4. Yeah, those both look like correct outputs. NFA dot was not being processed correctly. Your line 9. Quote, backslash, backslash. Unbackslashed quote here. already done all this. To where NFA would print out. Did I delete something somewhere? One, two, three, then quote. State 4. State 4 is just a backslash. Double quote, triple quote. There we go. I'll bet that does it. Okay. So, come in, we hit a quote. We can either get a backslash, followed by a quote, and then out, and then an actual backslash. This is the DFA. Or we can get anything else that is not a quote and advance and finish. Okay. I would include a backslash, but I don't want that. NFA, either, so quote, either backslash, quote, done, or not a quote and done. Okay. So these are behaving as I would expect. But I think the dot operator is going to kill us. So if we go to MIDI, what I really want is backslash dot. Backslash any character. Whoa. Oh, that's awkward. So debugging the dot. This is let's just narrow it down to the NFA. An allocator is null somewhere. So I bet I have is empty. So let's just simplify. Let's get just the table to log. Log tree, we'll come back to that. Log table. So I'm thinking right now. Me. What's any mean? Each state, blah, blah, blah. Conclusion text. If it's empty, nothing. Let's narrow it down some more. Oh, good heavens. Segfault. Is this something I can at least get a backtrace on. It's in parsing, is it? Compute DFA states. 4:15. Addition. Inclusion is null. Huh. Okay, I see what's going on here. I think, at least partially. Quit. Okay. Did print things out. And any looks fine. Okay. Back to our main file. Let's put -d back in. It did not crash. It'll just look okay. String, a quote, followed by not a quote, quote, except, or backslash anything, exclude nothing. Two, which is a quote, and done. That looks correct. Now, the hard part. I don't know if it's hard, but might as well log everything while we're at it. Okay. Oh goodness, how is it almost 6 o'clock? They compiled, they ran. Let's get those open in GIMP so we can take a look. Okay, the NFA first. Quote, backslash, anything, quote, or anything which isn't a quote, done. Okay, that's the NFA, DFA. Quote, backslash, anything. Yeah, not nothing. Or not quote, followed by a quote, followed by, yeah, perfect, perfect. Okay, so we're getting close. Mini VTalk. Now, 0 or more of those. So, we are running that build, which you cannot see because of GIMP. That is an NFA. Oh, what? There is no question mark. We need to figure that one out. But does it look right? Quote. Either. Well, this is easier to read. Find a quote. Go to 1. Either a quote or not. This looks the same as before. Does this look the same as before? Put this star here. Backslash. Either a quote followed by, well, followed by a not quote, followed by a quote, where we're done. Or we go to 4, where we get a backslash, to 5, which matches anything, and then goes to 3, where it matches that. Okay. So this looks exactly like before. This cannot add question mark after alternate. It makes no sense. Oh, it's in the pattern. If we have a question mark, it has to modify one of these operators. Oh. Okay, that's just bad logging right there. At least it will say you can't add a star after an alternate, which is not true, because that was a group. And that's our problem. Can we just do that and that? The question mark can stay here. Maybe not. You never know until you actually exercise the system. Unused variable previous operator, fine. Okay. All right, now we're talking. So we get a quote, then 0 or more of either a quote what? Oh, not a quote. Then back to here, or a backslash 5, anything, back to 1. If we can't consume any more of those, we go to 6, which is finishing with a quote. Okay, so we get a quote, followed by a not quote, back to here, or a backslash, anything, exclude nothing, back to 1. And if we get a quote here, we go to 3, which is our accept. I think that's it. Okay. We may have just fixed strings. So let's take a look at those DFAs, lads. I think that might be a good pausing point for the day. Okay, so just keep coming back, and the only way out. So these come back into each other. So it's a backslash anything or a quote. Then on a quote we exit. Star or backslash anything back to star, or anything that's not a quote back to star. The only way out of star is to hit a quote. Done. Whoo! I'm calling that done. So let's put it back into our big parser. Test.vb proj test vtalk. We want the line out of mini vtalk though. Put it into test.vtalk. Clean and test. Oh yeah, clean those up now. Okay. All right. This is exactly what we'd expect. If any character. That was the output. So we have a special case here in this one state. Oh, 6 o'clock. I don't want to leave this broken. Emit transitions. Emit DFA state. If else prefix whitespace. Oh boy. Yeah, we're all there. It's all working. Let's see. Let's just do regex. Now we can at least look at the image. Oh no. Oops. Okay. We have a table. These all look normal and sane. We have this output. String to 7. Round and round on 1. On that one. Yep. 7. 12. Back to 7. Yep. Which means our regex gets even more complicated. Check this out. Boom. Everything is here. Here's our quotes. Nice. Yep, it just keeps getting more and more complicated. There's the string chunk. Just like we read about. Okay, what we're gonna do, I don't have time. That was good progress. We're going to journal. String regex now working as expected. Had to do through DFA generation, not through code generation yet. Had to do better handling for empty inclusion set in several locations. I think there's no weird logging we left in. NFA, DFA. Yeah, looks good. Fixed string regex to work. Mostly to do with empty inclusion set. Exclusionary. Let's see here. Any. That'll remind you what I was talking about. Boom, done. Not a bad day's work. Thanks for hopping in, fellas. Oh, I suppose, ladies and gentlemen, I don't know. It is mostly mail on YouTube, but anyways, yeah, we're making good progress. This is great. You have a wonderful weekend, and we'll see you on Monday back with the game development. So thanks. Bye. Out.